Hi everyone, I'm gonna do this question for you guys today, and you can see it's two balls colliding to each other. So they've given two discs. Oh, so it's actually two discs, yeah. Two discs A and B weigh 2 pounds and 5 pounds respectively, and blah blah blah. They collide, and the coefficient of restitution between the discs is E equals 0.6, and they're asking us to determine the velocities just after impact. Okay, so we got one disc over here and the other disc over there. Okay, so this impacts at 10 feet per second at an angle of 30 degrees, and so that's B, and A impacts at an angle of 45 with the speed of 5 feet per second, and the given coefficient of restitution is 0.6. And note, you should. So after the collision, so we can assume. So we can assume that that both discs will be going in the same direction after the collision. So why I'm telling you this is, so it doesn't matter what direction you take, the speed you get will determine. So let's say you get, okay, let's say we assume it's going into the same direction, and if we get two positive values for the velocity, that means we are right. If we get one negative and one positive, which means one disk is moving to the right position and the other one's going on to the left. So it doesn't matter, right? The velocities will determine whether it's plus or minus. We can say we can tell at which direction they'll be going. So what I'm gonna do is, I'm gonna draw another diagram. So this diagram is for after the collision. So after the collision, let's say it leaves at VA theta and VB beta. So you can also see, right, that if you look at the diagram, B is larger and it's coming at a greater speed. So obviously B and A will move in the same direction after collision, right? So let's take the formula. So we know mass into velocity is moment, right? I'm sorry, not moment. I'm sorry, it's impulse. So impulse equals to mass into velocity, right? So before collision, you can write down. So we need to resolve. So impulse works on the horizontal. We need to resolve all our speeds. So 10 cos 30 into its mass, which is B is 5 pounds. So I'll write 5. And since A is coming from the opposite direction, we'll have to write minus 5 cos 45 into 2, right? Yeah. Equals 5, which is the mass of B. VB, you look at VB cos beta, right? Cos beta plus 2 VA cos theta. So what this section is, that's after the collision. So this is how you do it. This is the horizontal, the equations we need for the horizontal. Now let's focus on our vertical. Now when it comes to the vertical, the coefficient of restitution, there's another point I should tell you guys. Coefficient of restitution only works on the horizontal. We don't have to worry about the vertical when it comes to these type of questions. So if you look carefully, 10 sine 30, look, 10 sine 30. Let me write that with another color. So 10, this is 10 sine 30. That's equal to VB sine beta. Can you see? They're along the same axis. So if you draw it like this, you can see 10 sine 30 is going to be equal to VB sine beta. VB sine beta. And the same way for the other one, 5 sine 45 equals to VA sine theta. Okay, so we got one equation, we got two, we got three, and there's another one. Now coefficient of restitution equals to the change in final velocity over change in initial. So okay, so it's like this. So at the final, you have both particles going at the same direction, right? So if both particles are going in the same direction, so as the two particles are going in the same direction, for this part, that's after your collision. So this is after the collision. So if they go in the same direction, it's VA. Once again, you only have to focus restitution. I told you guys previously, it's only the horizontal speeds. So VA cos theta minus VB cos. I'm sorry, it's VA cos theta, right? I think I said cos beta, but it's cos theta minus VB cos beta. I hope you guys understood. Over. And when it comes to your initial part, I'll just name this as initial and final. Let's read it. So your numerator is your final and your denominator is initial. So if they come in opposite directions, you should add them. So it's 5 cos 45 plus 10 cos 30. So that's how it goes. It's addition because remember I told you it's change in the velocities, right? So you take the change in velocities if two particles are going in the same direction. This at VA, VB. So it's VB minus VA over, and this is final. And in initial, the case was this. This is a different example I'm taking. So if this is going in that direction and this is coming in this direction, so you can write this as VA, and this, to reverse it onto the other direction, you can write minus. So to reverse it when you reverse it, it becomes this, right? Minus VB. So minus VB is basically this. Same thing. I just reversed the arrow. So it would be VA minus VB. So minus and minus gives you plus. So that's how this becomes plus. So all you have to do is when you do calculations with coefficient of restitution, just remember, if they go in the same direction, it's subtraction. If they go in opposite directions, it's addition. So in most cases, for a collision to occur, the particles should come towards each other, right? In opposite directions, or one particle should travel faster than the other. But in this case, since both particles are colliding from opposite directions, your denominator is plus, and after your collision, they go in the same direction, so it's subtraction. Remember that. That's the way you can do these questions. You can quickly do it without wasting time, So E equals 0.6 into, now you use your calculator, into 4.16912. Oh, no, it's actually, my calculator was on radians. I just converted it to degrees, so it's 12.1957879 equals VA cos theta minus VB cos beta. So 0.6, that into 0.6 gives you 7.31747 equals to VA cos theta minus VB cos beta. That's your fourth equation. And you can simplify your first equation too, right? So your first equation is 10 cos 30 into 5 minus 10 cos 45. That giving you 36.23. I'll leave it like that. Equals to 5 VB cos beta plus 2 VA cos theta. This was your first equation. No mistakes. Everything's good. Yeah. So to solve this simultaneous equation, multiply the first equation by -2, right? I'll multiply that by -2, and then you can cancel off VA cos theta. So that's what I'm doing. So you get minus 14.63494 equals to minus 2VA cos theta minus 2VB cos beta, and you add this with 2VA cos theta plus 5VB cos beta. Yep. Oh, hold on a minute. This becomes plus 2. Because minus into -2 gives you plus 2, right? So these two will cancel off when you add them together. So now you 21.59506 equals 7 VB cos beta. So VB cos beta equals to 3.085. So now what you can do is we had VB sine beta, right? I'll write it in another color. We had VB sine beta equals to 10 sine 30, right? So you can write VB sine beta equals to 10 sine 30. And we have VB cos beta equals to 3.085. So you divide those two together, you get tan beta equals to 1.6207455, and when you find the angle, you get beta equals 58.325. So using that, we can write, you can use either equation, so it doesn't matter. I'll just use the second one. So VB equals 3.085 divided by cos 58.325. That gives you 5.88 feet per second. So we found the speed of B. So that shows you, that B slows down, right? And let me just check 10 cos 30. So 10 cos 30 is, yep, it slows down. So this is your speed for B after the collision. Now we'll have to find A. So if VB cos beta equals 3.085, you can use this formula to find VA cos theta. So you can write in 36.23 equals to 2VA cos theta plus 5 into VB cos theta. So VB cos theta is 3.085. Now you can find VA cos theta, which is 10.4025, and you have VA sine theta equals to 5 sine theta. So VA sine theta equals to 5 sine 40 cos. Yep. So now you divide, I'll name this as 6 and 7. You can divide 6 over 6 divided by 7, giving you tan theta equals to 0.3399. So now the angle is theta equals 18.77. That is your angle. Now we can find VA equals to 5. Let's use 10.4025 over cos 18.77. So now the answer should be 10.4025 over cos 18.77. That gives you 10.986. So if you round this into 3 sigma figures, you get 11.0, right? That is the speed for A, and that is the speed for B. This is B, and that's A. So if they ask you the direction for these questions, the angles we found are the directions. So your answers are these. These are your answers for the direction, and these are your speeds. I hope you all understood. If you guys have any doubts with anything, please drop a comment. And if you guys like my teaching, leave a like and subscribe. Thank you. Have a great